Hello and welcome to my video. As you can see from the title and here, today I am going to solve one of the math problems of South Korean College Scholastic Ability Test, which is the test that the high school students of Korea take near the end of the senior year to apply for the college. And I am also South Korean, so that pretty much explains my wacky English pronunciation throughout my videos. I have already graduated the college at this point, so I have taken this test many years ago. And the main reason that I decided to introduce some of the problems in this test is, well, because they are quite interesting, obviously. Some of the challenging problems required combined understandings on multiple topics of mathematics. For example, this particular problem requires knowledge of basic calculus, the graph of cubic function, and properties of the roots of the equation. Now let's take a closer look on the problem. So for real number k, the cubic equation 1 over 3x cubed minus x equals k has three distinct real roots, alpha, beta, and gamma. Now let m be the minimum value of the sum of absolute values of these real roots. Find m squared. So we are basically dealing with the roots of the cubic equation here, but instead of dealing them purely algebraically, we are going to take so-called graphical approach to the roots of the given equation. What does that mean? Well, alpha, beta, and gamma, the three distinct roots of the cubic equation, are x-coordinates of the intersection points between graphs of y equals 1 over 3x cubed minus x and y equals k. So let us draw this graph of 1 over 3x cubed minus x more accurately using differentiation. From here, we obtain the derivative of x squared minus 1, which is this. So this is the graph of the derivative. And from the sign of the derivative, you can see that this function has local maximum at x equals minus 1 and local minimum at x equals 1. And we can easily see that this function is symmetric with respect to the origin, and y values become 0 when x equals plus minus square root of 3 and of course at 0. Therefore, the graph of y equals 1 over 3 x cubed minus x on the xy plane is as follows. So, local maximum at x equals minus 1, local minimum at x equals 1, and symmetric to this point, the origin, and the x-coordinate of this point is minus square root of 3, and the x-coordinate of this point is square root of 3. So we have the graph. Now, alpha, beta, and gamma are x-coordinates of these intersection points between the graph of cubic function and the line y equals k. And here, assume, without loss of generality, that alpha is the smallest root, and then beta, then gamma. Then, in this figure, the position of alpha, beta, and gamma on x-axis is like this. Also, we will assume that k is not negative because the case of k negative with same absolute value as the previous one gives the same result for the sum of absolute values of three roots, due to the symmetry of the graph with respect to origin. Right, so under these assumptions, we can see that alpha and beta are negative and gamma is positive. Therefore, this expression can be written as absolute value of alpha equals minus alpha, and we have minus beta, and since gamma is positive, we just have gamma. So therefore, minus alpha plus beta plus gamma. So we have to minimize this. Now, we use the relation between roots and coefficient, also known as Vieta's formulas. Specifically, for the cubic equation ax cubed plus bx squared plus cx plus d equals 0, having roots alpha, beta, and gamma, alpha plus beta plus gamma is given as minus b over a. You can easily see why from this relation and expanding this part. So for our case, where the equation is 1 over 3x cubed minus x equals k, or 1 over 3x cubed minus x minus k equals 0, the coefficient of x squared is 0. So therefore, alpha plus beta plus gamma, the sum of three roots is simply 0. So we have alpha plus beta equals minus gamma. And previously, we have shown that the sum of the absolute values of three roots can be expressed like this. So using this, we have minus gamma plus gamma, which is 2 gamma. So m is simply the minimum value of 2 times gamma. And gamma is right here. And from the graph, we can see that gamma is greater than or equal to square root of 3, where this equality holds when k equals 0. Therefore, m, the minimum value of the sum of the absolute values of 3 roots, is 2 times square root of 3. And therefore, m squared equals 12. And this is our answer. So this was a nice little problem from famous South Korean test. We have used combined skills regarding differential calculus, the graph of cubic function, and relation between roots and coefficients of the equation to solve this problem in the simplest way. If you enjoyed this video, please hit like for this video and also consider subscribing to my channel for more interesting math videos. And I will see you in another video.